Today we are going to continue our discussion about the electricity. So in our previous lecture, we already studied about what is the electric potential and what kind of device can provide you a voltage difference. So intrinsically, electric potential is the voltage. So for example, like in United States, we use the 120 volt, and there will be a current flow from a higher electric voltage end to the lower electric voltage end. So this is how the current flows. But when the current flows, they will meet a device called a resistor, and each resistor will have their own resistance. And we find out that Ohm's law can be used to connect the three variables: voltage, current, and resistance. Today we are going to study more about the electric circuit, and then we are going to study what is the so-called electric potential power. So let's try to define electric circuit more rigorously. It is a closed path in which the electrons can flow and move. So if you have any gap in between the wire, there is no way the current, which is the electron, can flow continuously. So for example, when you have an open switch, what do we mean by that? It means there's a gap. When you turn it on, it means you close and connect the gap. So the switch is turned on, so the current can flow smoothly. So there are actually all the device, like your desktop, your smartphone, all the electronic device you use, basically they are built based on the circuit. So you can try to categorize the circuit into two main categories. The first is the series circuit, and the second one is parallel circuit. So what is the series circuit? So let's try to look at the diagram here, and you can have a basic sense of feeling. So you can see that the current will comes out from the battery and flow into the resistor 1, 2, 3, and back to the other end of the battery. And here it is the switch. So you can see that if the switch is open, there's no current, but when you turn it on, the switch is connected, so it becomes a closed path, which is a circuit. So the three resistors in series is the concept of the series circuit. You may thought it is very trivial. I will give you more physics later. And how about the parallel circuit? So the current comes out from one end of the battery and flowing into the three resistors. And you can see for each of the resistors, they have their own switch. So the current will passing through each of them, and the current will be combined together at this point, joined together, and back to the other end of the battery. So the three resistors in parallel is the so-called parallel circuit. So this is the real situation, but most of the time what you are going to see is a photo like this. So you have the switch here, and this is the device provide you the voltage difference, which is the battery in our case, or the generator. And the current will flow out from the battery into the resistor, and here we use the light bulb to represent the resistor. So the same here. Now you have three in parallel. The current comes out from here, and at the point A here, the current will split. So there will be current flow through all the three resistors. But did you see that actually here there is no current flowing through? It is because the switch here is on. Okay, so pay particular attention to that. So now let's try to study each of the circuit more carefully. The first is the series circuit. So it is a single path circuit for the electron flow. So which means there is no alternative path or wire for the electron to move within the circuit. So this is the only path. And you will find out as soon as you create a gap, some point within the wire or in the circuit, there is no way the current can flow. So electron flow ceases. So in an open circuit, for the series circuit, if you have a gap and if it is open, there's no way the current can flow. But now after the switch is closed, now the current can flow, and most important thing is that it is the same amount of current passing through every single resistors. So if people ask you about the magnitude or the amount of the current passing through the resistor 1, 2, 3, without even know the number, you should say they're all the same. And the third thing is that each of the resistors will have their own resistance. And you can sum all the resistance together in a series circuit. And the total resistance is simply just summation of 3. So therefore, in the series circuit, the more resistor you have, the bigger the resistance, which means more device, bigger the total resistance. But here I say that more device and less current. What do I mean by that? Because based on the Ohm's law, V equal to I times R. And because the V is the voltage across the battery, and V is the same, if you increase the number of the resistance, which means R become bigger, but V is a constant, so therefore I definitely will be smaller. So these are all the important physics about the series circuit. It is not just a simple 3 resistor in series. You have to consider about the property of the total resistance, what is the current, and voltage. So the voltage from the battery across the battery is fixed. However, the voltage across each resistor is not necessarily the same. So let me emphasize again. In a series circuit, the voltage across each resistor is not necessarily the same, but the current passing through each resistor is the same. And also, if you sum the voltage across each resistor together, for example, V1, V2, V3 together, the summation of the 3 voltage should be equivalent to the voltage from the battery. There are a lot of important physics here, so make sure you pay enough attention to the physics. The second circuit is the parallel circuit. So apparently you have branched pathway for the electron to flow. What does that mean? For example, the current comes out from the battery and entering to the point here. And at this point, which is the point A, the current has 3 directions to choose. The current can choose to flow through the way, or this way, or this way. So it is a branched path. However, if you have a break in any path, for example, in this diagram, I have a gap in the 3rd resistor here. The advantage you will see is that a break in any path does not interrupt flow of the current. So even though the current has trouble to flow through the 3rd resistor, but the current still will passing through the 1st one and 2nd one, and the current will combine still together at this point and back to the battery. So this is the structures. How about the property of the voltage, current, and resistance? So the first, if you try to sum the 3 resistance together in parallel circuit, the total resistance will become smaller, and also they will be smaller than individual resistors. If you calculate the total current is simply the current passing through each branches, and you simply just sum them together. And finally, the voltage across each resistor is the same for everyone. So you can see it is very different in terms of the physics. So let me refresh our memory again. In the parallel circuit, the voltage across each resistor is always the same. But the voltage across each resistor in the series circuit is not necessarily the same. However, the current is the same in the series circuit, but the current is different in each of the branches. However, when you sum all the three currents together, it will eventually equals to the total current. And finally, the most important thing, which is the thing people usually forget it, is about the total resistance. So the total resistance will become smaller in the parallel circuit, and the total resistance will be bigger in the series circuit. So there are three important physics quantities you should pay attention to. So now, let's try to study a little bit more about the electric circuit. So when you build the electric circuit, you will find out that the resistor plays a very important role. So you must have heard about this word, so-called the safety fuses. What does it mean? It is nothing but just the wire with the resistance. But if you create too big current, and when the current passing through this part of the wire, because of the internal properties, if you passing through this fuse with a very big current, then they will simply just melt. When the wire melt, it becomes an open circuit. It is no longer closed anymore. So this is a function of the safety fuses. So this is the way how people also do for the circuit breaker. So the circuit breaker simply just designed that. So in order to protect all the devices at home, they want to make sure there is an upper bound for the total current. So if the total current used among all the devices in the house is too big, they will automatically just turn it off. So now let's take a look about the first quiz today. So you have two identical lamps in the circuit connect in parallel. What will be the total resistance? So if you understand and pay attention to the previous introductions, you will find out that in the parallel circuit, the total resistance will be smaller, and it will be even less than the individual one. Now, let's have the second conceptual quiz. If you have the lamp powered by the battery, and charge will flow from where to where. So remember, this is a closed circuit. So the answer is, the current will passing through both to the battery and the lamp. Remember, this is a closed path. So in order for the circuit continuously flow, the current will just start from the battery and passing through the lamp and go back to the battery, and also from the end of battery to the higher electric potential end of battery and continuous flow. So this is very important. And also please remember, the electrons flow in the circuit is already in the wire. Okay, so the battery simply just provide them a voltage difference to move, to flow. So finally, let's introduce the concept of electric power. Electric power is actually the thing you will see on your electric bill frequently. It is the rate at which the electric energy is spent per seconds. So in the equation form, you can write it in terms of power equal to the current multiplied by the voltage. Current multiplied by voltage is a power, which is how much energy was consumed within 1 second. And the unit for the power is watt. So on your electric bill, you will frequently see the kilowatt. What is the kilowatt? It is the energy transferred or used within 1 hour at the rate of 1 kilowatt. Okay, so this is the total amount of energy spent. So kilowatt is energy per second and multiplied by the hour.